So combining like radicals, such as 3 radical 5 and 7 radical 5, we could actually put these together. So if I had 3 radical 5 plus 7 radical 5, what would you tell me that is? It's 10 radical 5. Right? The radical 5s are kind of like if they both had an x, you'd put them together. Same thing here, makes them like terms. So unlike radicals, if I have 4 radical 3 and negative 5 radical 2, they're different. I can't put those together. One's a radical 2, one's a radical 3. That's like having one x and one y. You can't put those together. So you may need to simplify radical expressions first to determine if they can actually be added or subtracted. So if I have like a radical 8 sitting there, you're going to have to simplify that. All right, so let's dive in and see what happens. So what is the simplified form of each expression? So if I have radical 3 minus 5 radical 3. Good. That'd be negative 4 radical 3. Because again, there's a 1 here. Yeah, since they're both radical 3s, it makes them like terms. And then 1 minus 5 is negative 4 radical 3. Right? The next one, 4 radical 7 plus 2 radical 28. Can you simplify either of those radicals? Yeah, we need to simplify this one first. Now this one's okay, right? 4 radical 7, I can't simplify the 7. Plus, and let's go ahead and simplify the second one. Good, 7 and 4, 2 and 2. So we get a pair of 2's times the 2 that's already out here is 4. And then I have a radical 7. So notice at that point, I didn't really care about what I'm adding it to. I was just trying to simplify this part. I had the pair of 2's. I multiplied it by the 2 that was in front. 2 times 2 gave me the 4. And then I had a single 7, so radical 7. All right, now are they like terms? Yes. 4 radical 7 plus 4 radical 7 is good, 8 radical 7. All right, but you have to make sure you're simplifying first. Yes, they have to be absolutely exactly the same under the radicals. So 5 radical 32 minus 4 radical 18. Can you simplify either of those radicals? Yeah. So if we do a factor tree on the radical 32, 16 and 2, 8 and 2, 4 and 2, I'm running out of space, 2 and 2. There we go. So pair of 2's gives me, what's pair of 2's and pair of 2's? 4 times the 5 that's already there is 20. Radical 2. Okay. Minus, and then we're going to do the second part of this. All right, so we have a pair of 3's times the 4 that's already up there. It's 12. Radical 2. Are they like terms? Yes. 20 radical 2 minus 12 radical 2 is 8 radical 2. Yeah, don't forget that number that's already sitting in front of that radical to start with. All right. How about the next one? Negative 4 radical 24 plus 7 radical 8. Good. 8 times 3 for the 24. We'll simplify this one. And then 4 and 2, 2 and 2. So we have a pair of 2's times the negative 4 in front. 8 radical 6. Good. 3 and 2. What? Simplify the second one. 4 and 2. 2 and 2. So we have a pair of 2's times the 7 out in front. 14. Radical 2. Are they like terms? No. So what is the simplified version of it? It's right here. If your radicals don't match, you can't add them together. But make sure they're simplified before you make that determination. Okay? All right. Questions on the adding and subtracting before we move on to multiplying? All right. So multiplying radicals. When multiplying, you do not need to have like terms. We've talked about this already this semester. You may use the distributive property to multiply the terms. So think about if I gave you 3 times x plus 2, we kind of talked about this already earlier, you would multiply and distribute throughout here, right? Same idea, I just have radicals this time. So what's radical 10 times radical 6? Radical 60. Good. Radical 10 times 3 is just 3 radical 10. One's in a radical, one's not, so I actually can't multiply them together. So am I done? Do I just stop there? Simplify. Yeah, just like before. Now I'm down to an addition problem, just like we finished up doing. Simplify if you can. So the 60, 10 and 6. So 5 and 2, 2 and 3. And we have a pair of 2's. So 2, and then radical 15 plus, can you simplify radical 10? No, that's just 5 and 2, no pairs. 10. Are those like terms? No. I'd be done right there. Bless you. Are you sneezing for me? All right, so what is the simplified form of each expression? So we have 4 problems, slightly different, some of them, so we're going to kind of go real slow through these, okay? That first one, though, is like the one we just did. So we will distribute. So what's radical 2 times radical 6? Radical 12. And then radical 2 times 5. Good, 5 radical 2. One's in a radical, one's not, so I can't actually multiply them. Can either of those simplify? The 12 can, yeah. So let's go ahead and factor tree that 12. All right, so on the factor tree of the 12, we end up with a pair of 2's. So 2 radical 3 plus, yeah, I can't do anything with that one, 5 radical 2. Like terms? Nope. So I'm done. So should you panic if you don't get like terms when you simplify? No. What about the next one? It's like FOIL. You guys will learn that FOIL's like a 4-letter word to me. You know what I mean? It's like profanity in my classroom. I hate the word FOIL. Really, really bad. I know you guys learn it that way, but it drives me nuts. Because if you're multiplying 2 terms by 3 terms, suddenly the term FOIL doesn't really work. Do you know what I mean? To me, it's just distributing. That's all you're really doing. All right, so here we go. So radical 5 times radical 15. Radical 75. Ooh, my radical got a little long. All right, and then we'll distribute radical 5 times a negative radical 3. Good, negative radical 15. Then what? Good, then we'll do 2 radical 3 times radical 15. 2 radical 45. And then 2 radical 3 times a negative radical 3. What's radical 9? This will be negative 6. Because again, if you're multiplying these, radical 3 times radical 3 is just 3 times 2 gives me 6. And I heard somebody say radical 9. What's the square root of 9? It's 3. All right. Ooh. So we multiplied it all. Can I simplify anything? Yeah, let's do the 75. So we'll do a factor tree here. Good. 25 and 3. 5 and 5. So we get a pair of 5s and a radical 3. So 5 radical 3. How about the radical 15? Factor tree that? No, it doesn't really do anything. So negative radical 15. I'll just bring that down. Good. 45. 9 and 5. 3 and 3. So we end up with a pair of 3s times the 2 that's already there. 6 radical 5 and minus 6. Any like terms and all that? No. I got a radical 3, a radical 15, a radical 5, and a 6. None of those are the same. So it looks ugly, but that is as simplified as we can actually get that one. Since the 5's like attached to that radical 3, like that's one piece. That kind of like me doing 5x minus 6. You wouldn't actually subtract those. Yeah, same idea. Yeah, radicals are kind of like variables if you think about it that way. They need to be matching just like variables have to. All right, do you guys want to try the next one? If you can do the distributing and all that on your own? Give it a try. All right, so here we go. Let's go ahead and multiply nice and slow. Check your work as I go, see if you can figure out what happened. All right, so radical 6 times 4 radical 3. Good. 4 radical 18. Okay. All right, next we're going to multiply radical 6 times negative 3 radical 6. That's negative 18. What's radical 6 times radical 6? Is 6 times 3 is 18. Remember, if you multiply two radicals with the same number, radical 6 times radical 6 is just 6. Oh, that's all right. Okay, that's totally fine. That's fine. All right, and then we'll distribute here. Negative 2 radical 3 times 4 radical 3. What's radical 3 times radical 3? 3 times 4 is 12 times negative 2, negative 24. All right, if you're multiplying two things and the radicals are the same, those are always going to cancel out. Right? Radical 3 and radical 3 make 3 times 4 times negative 2 gives me the negative 24. And then we distribute here. So negative 2 radical 3 times negative 3 radical 6. Good. That would be a positive 6 radical 18. Right? Because you have two negatives, which make a positive. 2 times 3 is 6. Radical 3 times radical 6 is radical 18. All right? From there, can we simplify these radicals? Yep, sure can. So if I'm simplifying my radicals, 18 is 9 and 2, which is 3 and 3. So we get 3 times 4 is 12 radical 2. What's negative 18 minus 24? Negative 42. And then here, I can simplify this one. So 9 and 2, 3 and 3. You're right. Pair of 3s times 6 is 18. It's all right. Radical 2. Any more like terms? 12 radical 2 plus 18 radical 2 is 30 radical 2 minus 42. I think there may have been one or two of you that had that for an answer. Who had that for an answer? 3 of you. All right, nice job, guys. Wow, 2 of them are from the same lab. All right. I mean, honestly, if you mess up the initial multiplying, you're kind of done from the start. All right, so really take your time, slow yourself down on these, okay, guys? The next one, radical 11 minus 2 squared. What's it mean to square something? Times it by itself. So really, if this whole thing is being squared, it means you're multiplying it by itself. It means you're multiplying it by itself. I have 2 of them. Right? Like if I ask you what's 4 squared mean, well, that means 4 times 4. It means I have 2 of them. So same thing here. It means I have 2 of them. And you're going to have to multiply the 2 of them together. All right, you guys ready? Radical 11 times radical 11 is 11. Radical 121 is not wrong. It's just not simplified. All right. Radical 11 times negative 2. Negative 2 radical 11. Negative 2 times radical 11. And then negative 2 times negative 2, positive 4. Can you simplify any of your radicals? No. But I can put them together, right? Right. These are like terms. What's that give you? Negative 4 radical 11. And then I also have an 11 plus 4. Try again. Plus 15. And there we go. That one wasn't quite as scary, right? The one before was a little frightening. All right. Questions about process. I understand it's easy to make little mistakes, but is there a process question? Okay. Radical 11 times radical 11. When I multiply here? That means radical 121 square root of 121 is just 11. Yeah, that's what we talked yesterday about that little shortcut. It's the same radical, it's just the number. All right. Moving on here. Let's talk about adding and subtracting complex numbers, meaning the parts that have i's with them. So combining like terms, just like with radicals, the i's are still, they're kind of like variables, right? If it's got an I with it, just like x's, we can put them together. The big thing here where I see students struggle is knowing what operation I'm asking of you and are the parentheses necessary or not. So in the first one, are any of those parentheses necessary? No, because I'm just adding, right? If it's just adding these together, I don't really need the parentheses. I'm just going to put my like terms together. So on the first one, we can have negative 5 plus 6, which is 1, and 8i minus 4i is 4i, positive 4i. So I is just like an x, just like any other variable. You're putting your like terms together. All right, how about the second one? Are my parentheses necessary? No. So what do we get there? I heard 4, which I agree with. And then what? Good. Negative 2i plus 1i is negative 1i, or just negative I. Again, if you ever put the 1 in front of that, that's totally fine. I'm never going to count off for that. How about that third one? Parentheses necessary? Good. Is this set of parentheses necessary? No, this set's not necessary. Negative 10 minus 3i. But this set, if there's a negative in front, it's like a negative 1 sitting there. You're going to have to distribute this. Now, technically, I could have that same idea up here, but if I distribute and multiply everything by a positive 1, does it change anything? No. Does it change if I multiply by a negative 1? Yeah, it does. So let's go ahead and distribute this negative. Perfect. Yeah, if there's a negative in front, think about that. If you distribute a negative 1, it changes things. If you distribute a positive 1, it doesn't change anything. All right, so once you distribute that negative, then it's like terms. Yes, it is. So negative 10 minus 4 is negative 14. Negative 3i plus 9i is a positive 6i. Okay, how about the next one? Parentheses necessary or no? The one side is, right? Like this one, like we read from left to right. So like in here, if I'm looking from left to right, there's nothing in front of this one, so these parentheses are not necessary. But here, yes, they are. So -1 times -2, +2, good, and a -4i. Ramon? It's perfect. -5 plus 2 gives me -3. -3i minus 4i is -7i. He's all over this one. Adding and subtracting is not so bad. Especially nice with these versus radicals. Radicals, you got to simplify those radicals and look for the like terms. Here, there's really no simplifying to do. You might have to distribute a negative. Would be about the only thing. All right, and the last one. Parentheses necessary? No. So I can just put my like terms together, right? What do we get? 18i. Yeah, because if you look, you have -3 plus 3 cancels. 9i plus 9i is 18i. Good. Questions, adding and subtracting, when to distribute a negative or not? Good there? Awesome. Why don't you guys go ahead? There's 4 problems. Take a couple minutes, do all 4 for me. All right, so that first one, do the parentheses matter? No, it's just adding. I don't have to worry about them. So like terms, -7 plus 6, -1, -3i minus 9i, -12i. And we're done. All right, second one, parentheses matter? Yes. This side matters. This one doesn't really matter. So -5 minus 8i. But here I have to distribute. So give me a +4 and a -2i. Like terms, -5 plus 4. Oh, hold on. -5 plus 4 is -1. And then -8i minus 10i. There's -10i. All right, next one, parentheses matter? It doesn't. I'm not distributing anything. There's a plus in between them, so I'm just adding them. So -2 plus 2 cancels out. That's just 10i. Good. And the next one, parentheses matter? Yep. This parenthesis doesn't matter because there's nothing in front of it. But this one I need to distribute. So we get -5 plus 10i. For what? Oh, yes. You're reading your answer backwards, but yes. So 3 and -5 is -2. And then -4i plus 10i is 6i. We haven't really talked much about the form of them, so it's totally fine. Typically, when you see the complex numbers, they're in the form a plus bi, where the I part goes last. I know, it's weird, especially when we're used to always putting the X stuff first. So at this point, I'm not going to be overly particular if you flip it. As long as it means the same thing, it's fine. Okay. We'll talk more about that as we get further and further in the semester. All right. So last thing we need to talk about, I love this little joke. I don't know if you guys read it yet. Why are you turning in a blank sheet of paper? All of my answers are imaginary numbers. What do you think I'm going to grade something like that? So when Ramon turns this in later, what grade am I going to give him? An F. I'm going to give him a big old 0. I'm going to laugh, but I'm going to put a 0 on the top of it. All right, so don't do that. The last thing we need to cover is multiplying complex numbers. We looked at multiplying with the radicals. Now we need to multiply with the i's. If you remember back when we first introduced I, we talked about I was the square root of -1, then I squared equals -1. So you're going to have to remember that little fact right here. I squared equals -1. You have to remember that. All right, so if I go to multiply, and again, it's distributing. So what's -2i times 5? It's -10i. negative 2i times I. Negative 2i squared. I times I is I squared. Just like x times x is x squared. But what does I squared equal? Okay, now be careful here. This is negative 2 times I squared. So that's negative 2 times negative 1, which is a positive 2. So negative 10i plus 2. So in other words, if you have an I squared, what's it doing to the sign of the number it's attached to? It's changing it. Yeah, because if I have an I squared, multiplying by I squared, the same thing as multiplying by negative 1. So that's just going to take, this was a negative 2, I flipped it to a positive 2. All right, how about the next one? 7i times 3i, 21i squared. Not just, it'd be negative 21, because that's 21 times negative 1, which is negative 21. Yeah, anytime you see an I squared, just replace that with a negative 1 and multiply it. All right, some more multiplying, distributing. So let's go nice and slow through this so we can make sure we don't miss anything. So as we're distributing, negative 3 times 4 is negative 12. Negative 3 times negative 2i. Good. Positive 6i. Negative 6 times 4. Did I say negative 6? 6i times 4. Sorry. It's 24i. I'm going to be like your parent this semester, okay? Like, you know what I mean. Don't listen to what I say, okay? It always comes out wrong. And then 6i times negative 2i. Negative 12i squared. All right, so we need to kind of clean it up a little bit. Yes? Yep, you can do that first. Just 30i. Yeah, remember if you're adding like terms, it's just going to stay an I. All right, if I have 6 ice cream bars and 24 ice cream bars, I have 30 ice cream bars. That didn't change when I added them. So negative 12, that would give me 30i. And then negative 12i squared will turn into positive 12. Good. And then like terms there, they canceled. So it's just 30i. So should you ever have an I squared left in your final answer? No, never do. All right. 4 plus 3i times negative 1 minus 2i. All right, so we'll distribute. 4 times negative 1. Negative 4. 4 times negative 2i. 3i times negative 1. 3i times negative 2i. Good. All right, putting your like terms together. Negative 8i minus 3i. Negative 11i. And then the negative 6i squared becomes positive 6. And then what's negative 4 plus 6? It's 2 minus 11i. Why don't you guys go ahead and try that last one on your own? All right, here we go. This last problem. 5 times 5 is 25. 5 times negative 3i. 3i times 5, positive 15i. 3i times negative 3i, negative 9i squared. Your like terms, they actually cancel out, guys. Negative 15i plus 15i is nothing. So then I have 25. Negative 9i squared is plus 9. That's just 34. Now, that's the first time we've gone through this process and you suddenly don't have any eyes left. Look at the original problem where you started. What do you notice about what you were multiplying? Good. The first number is the same. The last number technically is the same, but the sign in the middle is different, right? So anytime you have this, this is called, these two numbers, these are called conjugates. Little vocab term for you there. Conjugates means one's plus, one's minus. All that means. When you're multiplying them, one's a plus, one's a minus. That's the only difference between them, right? Everything else is the same. So you could think of it as like A plus B. I cannot write A minus B. Right, so the first number is the same, the last number is the same, just the signs in the middle is different. It's the only difference between them. Okay, so if you hear me use the word conjugate, that word will come up as the semester goes on. That's what I mean. They're just the same thing but different signs. So if we look at the next part, it's actually talking about complex conjugates. It's when you have the i's in them. So you can use conjugate for things that are not complex, do not have i's, but in this case we're talking about them when they have an I. So if you look here, the first numbers are both -2. The last numbers are both 7i. One's a plus, one's a minus. Okay, again, first numbers are the same. I don't care one's negative here. This one's going to be negative also. Exact same number, just different signs. So what's going to happen when I multiply these together? Will there be any i's left over? No, you're going to get a real number. So what's -2 times -2? -2 times 7i. -14i. -7i plus or times -2, +14i. -7i times 7i, -49i squared. So hopefully you recognize, hey, those are conjugates, so you know that's going to be gone. So then I have 4 plus 49, which is 53. So if they're conjugates, your i's will vanish off there. You'll have just an actual number for an answer. So could you tell me the conjugate? If I give you 4 minus 6i, what's the conjugate? 4 plus 6i. Look at that, you just filled in half a problem. Wow. Could you multiply them together now? Yeah, we can multiply these now. 4 times 4. 4 times 6i. -6i times 4. -24i. You know those are going to cancel. -6i times 6i. -36i squared. You know those like terms in the middle cancel. So we get 16 -36i squared plus 36, which equals 52. Good. Last one on your own. Find the conjugate and then multiply them together for me. All right, guys, let's go through the last part here. All right, so what is the conjugate of -8 plus I? -8 minus I. All right, when we multiply -8 times -8, positive 64. -8 times -8i, positive 8i. I times -8, negative 8i. And I times negative I squared. So those cancel. So I end up with 64. Negative I squared becomes +1, which is 65. They look pretty good walking around. All right. Sorry, guys. I know today's been like a crazy busy. We got a lot kind of jammed into today. I'm going to give you the last 15 minutes to work on homework. As you're working on your homework, make sure that you're referencing the notes, okay? Because it's kind of a hodgepodge mix here and there and everywhere of adding, subtracting, and multiplying, some with radicals, some with i's. Make sure you know what to do with them, okay?